This is day 5 of our unit on solving systems of equations. But today is the day that we start looking at solving 3 equations and 3 unknowns instead of just 2 equations and 2 unknowns. So let's get started. Well, here's the key. Rather than trying to deal with 3 equations at one time, what we do instead is we deal with 2 of the equations at a time. For example, I could do the top 2 equations, and then I could deal with the bottom 2 equations. It doesn't have to be the top 2 and the bottom 2. I could have done, for example, the first and third, whichever you prefer. But just so I can put these nice little braces around them, I'm going to do the top 2 and the bottom 2 today. Now, we're going to do the elimination method today. You can also do the substitution method, but we'll save that for tomorrow's lesson. Now, when you do the elimination method, you have to decide right from the beginning which one of these variables you want to eliminate. So I like picking a variable that has a no leading coefficient other than 1 in both equations. So for example, look at this z right here. See how this z, there's no number in front. The leading coefficient is 1. And that z is in both the blue equations and it's in the red equations. So because of that, I am going to decide to eliminate the z's. Okay, in fact, I'll just highlight this whole situation to show that I'm all about eliminating the z's today. Okay, so now here's what I mean by the blue and the red equations. I'm going to recopy these top 2 equations very carefully so as not to misplace a negative sign. So this is going to be 4x plus 2y minus 6z is equal to negative 38. Alright, that I've just recopied the top equation. Now the second equation I'm just copying, so 5x minus 4y plus z is equal to negative 18. Okay, so here I have the top 2 equations. Similarly, I'm going to copy the bottom 2 equations, like this. So here I've copied the bottom 2 equations in red. So, like I said, we were going to eliminate the z's. If I'm going to eliminate the z's, I have to eliminate the z's in both the blue equations and the red equations. So, how will I do that, you ask? It's a good question. Here I've got a negative 6z. So if I can make this into a positive 6, that would get it done. So that's why I'm going to multiply this equation by 6. Okay, the top equation will stay what it is. So that's why I'm going to have 4x plus 2y minus 6z equals negative 38. That's the top equation, stay the same. And down here I'm going to have 30x minus 24y plus 6z equals negative 108. So when I go to combine my like terms, the z's cancel out as promised. And so now I have 34x negative 22y, okay, is equal to negative 146. Now before I call this equation ready and finished, I like my numbers to be as small as possible. I'm noticing that these are all positive. I mean, not positive, they're all even. So that means at least they are all divisible by 2. So why not make life easier on yourself and divide by the greatest common factor. Make them smaller. So this is going to become 17x minus 11y is equal to negative 73. Okay? So, put a box around that. This equation is now ready to go. I'm going to use that later. Alright, so remember, I put the top two equations together and eliminated the z's. Now I'm putting the bottom two equations together, and I'm again going to eliminate the z's. Let's see. This time I have a 7 and a 1. If I could make this into a negative 7, then they would cancel. So I will multiply by negative 7, like you do. So I'm just going to recopy. So now I'm going to have negative 35x plus 28y minus 7z is equal to 126. Now the bottom equation just stayed the same. X plus 3y plus 7z is equal to 38. Alright, and sure enough, if I combine like terms, the z's go away. So that's going to leave me with negative 34x plus 31y is equal to 164. I can't make these numbers any smaller. 31 is a prime number, so I am stuck with some kind of big numbers. But that's okay. So I combined the top two, and I got this blue equation. I combined the bottom two, eliminated the z's, and I got this equation. Now I'm going to take these two box equations and put them together in a new system. Alright, I'm just going to stack them up. Blue, red. So let's see. 17 minus 11. Alright, so let's see. Let me try to keep it color coordinated for one more second. So what I've got now is 17x minus 11y is equal to negative 73. Okay, that was just the blue box equation over here. And now the red. Alright, I'm just copying down this equation right here. So that's going to be negative 34x plus 31y is equal to 164. Alright, so I just need to put these two equations together and then solve them. So I'm noticing that 17 goes into 34 evenly. 2 times 17 is 34. So I'm going to go ahead and try to cancel these x's. So if I cancel the x's, I can do that by just multiplying by 2. Alright, if I do that, then I'm going to have, in the top equation becomes 34x minus 22y is equal to negative 146. Now the bottom equation just stays what it is. So negative 34x plus 31y is equal to 164. Alright, so if I combine like terms, these go away. This is going to give me 9y is equal to 18. Yes. Okay, so finally, of course, to get y by itself, I'm just going to divide by 9 on both sides. So that's going to give me y equals 2. Kabam! Alright, that is one of the 3 variables I need. But I still need x and z. So let's stay over in this area right here. Here we just have two equations, two variables. We've been solving equations and systems like this for a week. So whenever we would get one variable, we would just take this answer and plug it back in to get the other one. So let's go ahead and just do that now. Okay, so I've got y equals 2. So let's see. I'm going to take this 2 and substitute it back in. I could either put it into the blue equation or the red equation. I'm going to do the blue equation. Okay, so I'm just recopying the blue equation, okay? So the blue equation was 17x minus 11y is equal to negative 73. So if I put this value of 2 in, it becomes 17x minus 11 times 2 is equal to negative 73. So that's 17x minus 22 is equal to negative 73. Adding 22 to both sides gives me 17x is equal to, so that's going to be negative 51. And then, of course, you divide both sides by 17. Okay, and that gives you x is equal to negative 3. Kabam! Well, now we have two variables, and we just need the third. Once you have the two variables, it's very easy to get the third. What you need to do is go back to the original equations, one of these three, and just pick the one that seems easiest to you and substitute both of the values that you just found at the same time. Okay, I like the third equation. All the coefficients are positive, so I'm going to go with that. So what I'm going to do is just recopy that down here. So here I've got, whoops, not 3. I've got x plus 3y plus 7z is equal to 38. All right, so, but now I know what y and x are. So I'm going to substitute both of those in. So this is going to become negative 3 plus 3 times 2, okay, because the y value is 2, plus 7z is equal to 38. All right, so this is going to become, so this will be negative 3 plus 6 plus 7z is equal to 38. Putting these two together, that gives us 3 plus 7z is equal to 38. Subtracting 3 from both sides gives us 7z equals 35. And finally, dividing both sides by 7, we find that z is 5. All right, so finally we have all three variables. We have x, y, and z. Now, remember back when we learned about ordered pairs, and they were always in the form x comma y. Well, there's a such thing as an ordered triple, and it will always be in the form x comma y comma z. So let's go ahead and record our answer as an ordered triple, which in this case would be negative 3, comma 2, comma 5. So that would be the final answer to problem number 1.